Now we come to production scheduling, right? So after having seen how much I need to make of gear, a particular gear, in this case, I'm taking the gear 6A, which is the gear that goes into assembly number 6, gear assembly 6, right? And then 6A uses a particular type of blank to convert that blank into the gear called 6A. So now I'm in a very detailed level where I'm talking about just 6A. This is on the factory floor, right? I'm saying I want to make 6A for a particular month, which is October 2019, right? Now, there are two steps, as I said, in making that gear 6A. One is hobbing and the other is broaching. So the hobbing, think of it as cutting the teeth into the blank in the outside, right? The broaching as cutting the things that I need inside, right? The circular thing and that particular joint kind of thing, which is used to join this gear to another gear, the shaft and so on. So those are the two steps. And these are done in what are called workstations. So first I have to do hobbing, take the blank and hobbing. So I get a gear which is called the outside teeth. Then I have to go to the workstation called broaching, where actually I do the internal shaping of that gear. And then I'm done with that gear, right? I've now got gear 6A, which I can then use to assemble with 6B and create the gear 6, which is later down in the production. So I'm only now talking about hobbing and broaching in the two workstations, workstation 1 and workstation 2. Now there's a concept of scrap I want to introduce, right? Scrap means that when you make these gears, you will not always get how much you want to actually make, because some parts will not have the correct shape for some reason. The machine is overheated, or because the particular blank was not a good quality. So when you get to inspection, which is a quality inspection, you might actually have rejects happening. So some parts of the production will actually get rejected. So that's the concept of scrap that shows in the spreadsheet. So when it says standard scrap 2.5%, what we're saying is that I expect that I will only get 97.5% of the loading into the hobbing workstation. So if I start hobbing 100 blanks, I'll only get 97.5, or rather, to make it more easier, if I start 200, I will only get 195 at the end of hobbing, which are good parts. The rest of it's scrapped. The 5 parts are not good to be used, so they are scrap, means they're thrown away or sold as scrap and so on. So that's the concept. And then you see what's called the loading. So the loading is really important, and I want to spend a minute on that calendar piece right here. So this is for the hobbing workstation, which is the first workstation that manufacturing process. So here I'm saying, based on my production plan for gear 6A, right, which we saw earlier, for the month of October, if you actually see, I want to make 9,000 units. So that is the actual target. So if you go up to the top of the worksheet again, you'll see that the target is 9,000, but I might not actually get 9,000. So if the target is 9,000, then the detailed scheduler says, this is what I want to make every single day of the month, right, to reach that 9,000 units. And each day, actually speaking, so you see the quantities there. Day 1, I want to make 400. Day 2, I want to make 800, and so on. And there is a reason why you will see that only some weeks have quantities in them. The reason is because I want to make gear 6A on alternate weeks. So you see the week 1, the quantities are there. Week 2, there is 0 quantities, because that machine is now being used to make another gear during that week. Week 3, I come back to making 6A. Week 4, I make some other gear. Week 5, I again come back to making 6A. So this is typically how machines are scheduled. They make multiple products, and they have to change over from one product to another, and that to be set up to make the new product. So this is the picture for October 2019. This is what I want to make for the hobbing workstation, and the next calendar shows what I want to make in the broaching workstation. Now you'll see that the quantities for broaching that I planned is already less than the quantities for hobbing. So you see that while I want to do 800 in hobbing, I want to do 780 in broaching. And that's because of the scrap factor I told you about. Like 2.5% of that 800 will get scrapped. I know that that's the average that gets scrapped. So my goal itself is only to do the broaching for 780 because of the 2.5% loss in the process. So this is the monthly amount that I want to make for each of these products.
So this necessarily assumes, Shiv, that hobbing is done before broaching. You can't do it the other way around.
Yes, absolutely. There is a sequence involved. You're very, very right there. So I want to get the hobbing done, then I want to get the broaching done. Now, this actually, yeah.
So you have 0 on Monday, right? Presumably you have 0.
Yes.
0 on Monday because you have not got any units from the hobbing workstation.
Yes, absolutely. And this will become very clear in the following table, right? Where I'm showing the yellow table below, which shows what's the actual detailed production schedule for 6A in October 2019, right? So you see the first day of the month, there are 2 shifts. I'm operating 2 shifts in my factory. That means morning shift and an evening shift, right? And whenever I start the week, the very first day, the Monday of the week, the first shift in the hobbing workstation, I'm going to do changeover. That means those 8 hours, I'm preparing the particular hobbing workstation to make gear 6A. There are a number of settings that need to be done to make sure it is cutting at the right frequency and all of these things. I need to inspect those settings, record those settings, do some trials and all that. So that takes the entire shift. So that shift, there's no production that's expected in the hobbing workstation. Now it's ready for production. So when it comes to shift 2, the labor comes in, they start doing the hobbing, and they plan to make 400 units in that shift. And then that machine keeps running on 6A for the rest of the week. So you can see that Tuesday, Wednesday, Thursday, Friday, if you go to the right, you'll see that the quantity 400 is being planned regularly. But when it comes to Saturday, I want to stop. Right? I do only 1 shift on Saturday, the 6th of October. And then I have to leave 1 shift for what's called maintenance. So every time the machine has run for a week, I need 1 shift of maintenance, which means I need to possibly clean the machine. I need to lubricate the machine, make sure that there is no heating issues. I want to do some some sort of lubrication, whatever. So that shift is dedicated to maintenance. So essentially, in this case study, we only have 6. We have only 6 days, of which 2 shifts are used for, 1 for changeover and 1 for maintenance. And so I have the remaining 10 shifts in which to actually do the production. So that's what you see in the plan. There's only 10 shifts that are actually planned. Similarly, if you see the next line, you'll see that for the broaching machine, in a very similar way, first on a Monday morning, I do maintenance for 1 shift. Then I do changeover. That means I'm setting up the broaching machine for gear 6A. That takes a whole shift. And on the next day, Tuesday morning, is when I start the broaching operation. And I only plan 97.5%, 390 units, because I know that the 400 that's made in the previous, so the shift 2 of the 1st of October, those 400 I plan, only 390 I know will be actually made. So that then jumps into the next machine, right? That's why you see 390 on the shift 1 of the 2nd October, and so on it goes. And then you see on the Saturday, you'll see that the broaching also stops. And then yeah, exactly. So that's the point.
Okay.
Now this is the way it works. And then if you keep going to the right, you'll see for the next week, this machine is not used. Hobbing and broaching are in the plan. They are zeros because I'm now making 6B. So you see after the changeover, gear 6B is starting. And Sundays are holidays, right? That's what it's showing. But the next week, if you see, gear 6B is being made in that particular hobbing and broaching line. And no production of 6A is happening. And then the following week, if you keep going to the right, you'll see again, I will start making 6A. So after the maintenance and changeover, now I have started making 6A. And the following week, 6B, and so on. So that's the pattern you'll see throughout this plan, right? So this is the detailed schedule for the machine line for that month, right? So that's what we're seeing here. In the plan, right? This is my plan. My actual may actually be different, which is the next table. So if you come to the next table, it actually shows the actual production. So the first table says, this is my plan, right? I want to make so much in each shift, in each machine. But then you see the actual, you'll see that the number that's actually made is very different from what we anticipate. Because in reality, a worker could make a mistake, or there could be a problem in the machine, or there could be some defects in the incoming raw material batch that actually cause more scrap than less than anticipated, and so on. So in the second table, you'll actually see that the actual quantities that are being made from hobbing and broaching are very different. So I plan to make 400, but I actually only made 388. Similarly, the next shift I plan to make 400, I actually hit 390, which is my full plan. And there are some shifts where I actually make 378, and so on and so forth. So every shift you get the actual production. Now you also see some cells that say breakdown maintenance. So what happened there is that the hobbing machine had an unplanned breakdown. So unplanned breakdown can happen due to many reasons. It could be an electrical fault, which meant there was no power on that line, or it could be a jam in the machine, which meant the machine had to be completely taken down and some of it had to be taken down and rebuilt, or it could be a flywheel which got broken. So there's a number of reasons for why breakdown maintenance happens. And when that maintenance happens, in a very simple way I've shown here is that the entire shift production is lost. So I wanted to make 400, but I didn't make anything. There's zero production. In the 3rd of October, first shift in the hobbing machine, there was a breakdown and there was no production. And you see the impact further down. If you see the same day on the second shift, the broaching, I plan to make 390, but I'm making 0 because there's no hob parts coming to my broaching area at all because of the breakdown maintenance. So you see how breakdown maintenance actually disrupts further in the production chain, right? Because of that sort of thing happening. So you see the actual quantities, yeah.
So when you are doing maintenance, I understand, if there are 5 machines in the entire line, then each worker is doing maintenance on each of those machines, and that is understood. But if there is a breakdown, let's say one machine has broken down, then the other 4 are also idle because one has broken down, right? The other 4 can't continue doing their task.
Yes, if it's subsequent in the production process, right? So if the output of this machine is required for other machines to work, then they will all have to be idle, right? That's why you don't want to have too much dependence on just one machine in the organization. But if you have 4 hobbing or 5 hobbing machines, right, in parallel, and one of them broke down, there's no problem because you can continue using the other 4 hobbing machines. Then there will be a ripple effect, right? Because the product is the semi-finished product or the work in progress is not available for further steps in the production operation.
Understood. The next, sorry, you were saying something.
I'm just going to conclude saying that the last row you see is the cumulative output, right? That means after broaching, that's when my finished the gear is fully available. How much I'm able to make. So that will keep adding, right? Every day's production, every shift production will keep adding. And then you'll see at the end of the month how much I actually made for gear 6A, right? So the last thing will show you how much was made. And it's less than what I actually planned, right? So if you go all the way, you'll see that the cumulative output at the end of the month was 8690 units, right? So the last day of the month, after shift 2 was finished, I was able to make a total of 8690 gear 6A against a production schedule of 9,000. So if you go back to our previous table and see October 2019, how much I wanted to make for gear 6A, it was in the previous worksheet we saw, it was actually 9,000. But in reality, I could only make 8,690 units, right? So that is why we're trying to say that the actual production will differ from the planned production. And the closer you can get your actual production to the planned production, the more your overall efficiency is from a manufacturing perspective.
Is that the key question in this, Shiv? I mean, that you would want to see? the effectiveness or efficiency or some metric, some measure of how good production planning is and execution is?
Yes. There is a very commonly used metric called overall equipment efficiency, and there is a very nice illustration that shows how that's calculated. So, I wonder if you can drop that particular picture, Milind.
You want me to bring up the picture, Shift?
Yes, for the overall equipment efficiency. That will show how it's calculated. Yes, so this is the most commonly used metric to evaluate the manufacturing performance, right? At the end of the day, there are world-class factories that do really, really well, and there are factories that are not that good, that don't do really. And how do you differentiate how good is the manufacturing system? The most commonly used formula for that is overall equipment effectiveness. It's a gold standard for measuring productivity. And that actually depends on, or it's a compound metric. It's based on three things, right? The first thing is the availability. So the availability is how much time was lost from the planned production hours. So we saw that the hobbing machine had a breakdown in one of the shifts in the month, right? So if your plan for the whole month was, I don't know, like 20 shifts, right? And one of those shifts was a breakdown. So that means that time is lost. So out of the 20 shifts, say 8 hours each. So 160 hours was the planned production hours in this case. But the lost time is 8 hours, let's say. So you basically, the availability is the 160 minus 8 divided by 160, right? Which is basically 152 by 160, which then translates to 95%. So your availability for that month for the hobbing was 95%, right? So that's the first part of the OEE. So if you had the machine was fully available, there was no breakdown, there was no lost time, then your availability is 100%, which is the ideal scenario. So if your maintenance, you are given already a shift for maintenance in the beginning of the week, if that was done really well, you should not have lost time because your plan should be equal to your actual and your availability will be 100%. But in reality, these things happen, so your availability will be less than 100%. The next part is performance of the machine, which means what's the actual machine speed divided by the design machine speed. So this means that in some operations, in some types of manufacturing, you want the machine to be able to produce a certain number of units per hour, but in reality, the machine may actually be running slower, or the people that are running the machine may not be most efficient. So your actual output is slower, or the production is slower than what you planned. So that affects performance. So that is the, if the design machine speed was 100 and the actual was only 90, the performance becomes 90%. And then finally, the quality, which I talked about as scrap, right? Which basically says, if I wanted to make 100 units of good product, but 5 of those actually turned out to be bad product because they didn't meet the specifications for quality or whatever, and they become scrap and they're thrown out, then I get only 95, right? So 95 by 100 then becomes quality percentage. So the quality percentage will be high when your input materials are of high quality, your process is very well defined and stable and doesn't create errors, then you get 100% quality. If some of these things are not there, then your quality will actually decrease, and some of the product you make you have to throw away, right? So that's quality. So OEE, overall equipment effectiveness, is really the multiplication of all these three ratios. So if it's availability multiplied by performance multiplied by quality. So if your availability is very good, if your performance is very good, and your quality is very good, then your OEE will be very good, right? In the industry, even very mature manufacturing companies are not achieve anywhere near 100% OEE because they would have some losses. So for example, if your availability was only 90%, your performance was only 90%, and your quality was only 90%, then you can imagine the OEE will quickly drop, right? Even though you are 90 on each, when you multiply all the three 90s, now you are looking at 72, 73% OEE, right? Which is kind of what is the best in class. Many companies are at 40, 45, 50% OEE. So this is a very difficult metric.
45% OEE, huh? That is what it is.
Yeah, many companies in the industry, average companies will be 40 to 50% because there will be 80% in each, right? For example, right? But when you multiply cumulatively, it becomes hard to achieve more than 50, 60%. So world-class companies are in the 70 to 80% range of OEE.
And the reason you have decomposed the OEE into these three things, availability, performance, and quality, is because the kind of control that you need for each of these is different. What you need to do to improve availability is one thing, what you need for performance something else, and for quality something else.
Absolutely, that's a really good point. The responsibilities within the manufacturing company are also somewhat different. So for example, the maintenance department is mostly evaluated on the availability. So if they are doing a really good preventive maintenance and so on, the availability will be very high. The human resources training, that affects performance. So if the people that are running the machine are not fully trained in it and they are not very skilled in it, it will slow down because somewhere somebody will not be able to meet the required speed with which they are doing some operations. So typically that affects performance. And then the supply side, right, the procurement department, etc., they have a lot to do with quality, but also the training and everything affects quality. But definitely, if you don't get good raw materials, your quality will suffer. So quality is, so these are all somewhat different, like who's got more influence or impact on these three things.
Okay. Should we go back to the Excel sheet?
Yes.
So we were done with that Excel sheet, no, Shiv?
Yes, that is an interesting Excel sheet. And some of the questions I'll have, for example, is what is the OEE, right, for the different machines? And does it change week to week? Is hobbing better or broaching better? In terms of OEE, right? So those are some of the questions to be analyzed.
Okay.
Another question that arises is there a difference between shifts? A lot of companies consider this deeply, right? Because sometimes, especially when you're running night shifts, performance, for example, may not be as high as in a day shift. So do you see any differences in the shifts in this case, right? It's also a good question to analyze.
Okay.